Hi class, Professor Dave, welcome back. Today we're going to do absolute value with equations and inequalities. So let's get started. Okay, so we're going to do these three things today. So the absolute value of x donated by these lines, absolute value of x, is really just the positive value of x, or it's the real value of x neglecting the sign positive or negative. So the absolute value of 5 is just equal to 5. The absolute value of 8 is just equal to 8. But the absolute value of 5 is of minus 5 is equal to 5. That is, it's the real distance away from 0, or its real magnitude. And the absolute value of minus 2 is just 2. So if it's positive, that's what you get. If it's negative, you just take the positive. So it's really its magnitude. So we can have equations with absolute values. So let's solve these. If absolute value of x is equal to 3, then x can be equal to 3. That clearly works. Or x is equal to minus 3. And that's the idea. If absolute value of x is equal to 5, we had x is equal to 5, or x is equal to minus 5. Both work, because the absolute value of minus 5 is 5, and the absolute value is 5 is 5. Now, the absolute value of x is equal to minus 2 can't happen. No solutions. Because the absolute value is always 0 or positive, because it's the magnitude or the true distance from 0. Okay, let's solve this equation. So we can have equations like this. So what we have is x minus 5, x minus 4 is equal to 7, or x minus 4 is equal to minus 7. So that's what we do. Whatever is in the absolute value, we have it equal to 7 or minus 7, and then we can solve. So if we add 4 to both sides, x is equal to 11. And here we have x is equal to a minus 3. Okay, so here's a solution, and here's a solution. We get two solutions with absolute value, because if it's negative, absolute value gives us the positive as well. So let's test them. Plug in 11. 11 minus 4 is 7, and absolute value of 7 is 7. So that one worked. And let's try this one. The absolute value of minus 3 minus 4 is equal to the absolute value of minus 7, which is equal to 7. And so that works too. Now let's solve this one. So the way we do them is x minus 2x minus 6 is equal to 10, or 2x minus 6 is equal to a negative 10. Because if it was equal to negative 10, we take the absolute value, we get 10. Since the absolute value of minus 10 is equal to 10. Okay, so we just solve these two. So 2x is equal to 16, and x is equal to 8. Plug that in. 16 minus 6 is 10. Absolute value of 10 is 10. Here we have 2x. Add 6 to both sides is equal to minus 4. And x is equal to minus 2. Okay, another example. So 5x plus 10 is equal to 25, or 5x plus 10 is equal to a minus 25. Either way, when we take the absolute value, we get 25. Solve this. 5x is equal to 15, and x is equal to 3. 5x is equal to a minus 35 divided by 5, and x is equal to a minus 7. Check both those, and it works. Now this one, absolute value of this is equal to minus 9, can never happen. Absolute value of something is always positive, so no solution. And then if we have something like this one, we have to solve for the absolute value first. So just pretend like this whole thing is x. We subtract 8 from both sides. So we have is equal to 12, divide by 4. And then we just do what we did before. Or okay. So then 2x adding 5 and x is equal to 4. And 2x adding 5 and x is equal to 1. And there's our two solutions when you have absolute value. Let's check an answer. Plug in so we have 2 minus 5 is equal to minus 3. Absolute value of minus 3 is equal to 3. So we have 4 times 3 is 12, plus 8 is 20. And that one worked. And the other one will work too. Okay. All right, so now we can have absolute value with inequalities. We can have the absolute value of x is less than 3, or the absolute value of x is greater than 4. Two different types of situations, and we handle them differently. In this case, we have x's in between 3 and minus 3. Because if we take the absolute value of minus 3, we get 3. So if it's more negative, say minus 4, we get numbers that are bigger than 3. Absolute value of minus 4 is equal to 4, but that's bigger than 3, so that doesn't work. And any numbers out here, of course, doesn't work. So it has to be this combined. 0 works. Absolute value of 0 is equal to 0, and that's less than 3. Absolute value of minus 2, right? Minus 2 works, is equal to 2, and that's less than 3. Okay. Now this situation, we have x can actually be more negative than minus 4, or okay, x can be greater than 4. Right, say if x is equal to 8, then absolute value of x is equal to 8, and that's greater than 4. So all these work. Any number greater than 4 is going to work. But also, any number more negative than minus 4 will work. Say minus 10. Absolute value of minus 10 is 10, and 10 is greater than 4. So we have both these situations. This one, it has to happen at the same time. Minus 3 until 3. But this one, we get the two situations. So let's solve this one. Okay. So we have x then is just less than or equal to 8, but it has to be greater than or equal to minus 8, and that solves it. Okay, clearly minus 8 works because it's equal to 8. 8 works. Any number in between will be less than 8, so we got it. Let's solve this one. Well, we have 2x minus 4 has got to be less than 6, but it has to be greater than minus 6 at the same time. So we can add 4 to both sides. It's less than 10. And if we add 4, that'll be greater than minus 2. Now we can divide both sides by 2. X would be less than 5, but greater than minus 1. Okay, so all those points work. And let's try 0, for example. 0 is in this set. Let's try x is equal to 0. Plugging that in. 2 times 0 is 0, so we have an absolute value of minus 4, which is just equal to 4, and that is less than 6. Now, if we try x is equal to 7, it's not in this range, it shouldn't work. 2 times 7 is 14. 14 minus 4 is 10. The absolute value of 10 is 10, and that is not less than 6. Now, minus 1 isn't in there either, right? The solution set is also with parentheses minus 1 to 5. In interval notation, graphically, it would be from minus 1, we have 0 out to 5. And it's open circle because they're not included. And all these guys. Okay. Now, so if we try minus 1, it's just not in there, but it's right on the board. If we plug in minus 1 into here, 2 times a minus 1, minus 4, absolute value is equal to absolute value of minus 6, which is equal to 6, and that is not less than 6. It's actually equal to 6, but that's the border, and 5 also works. 10 minus 4 is 6, and we have 6 is not less than 6. Okay, hope that you get that understanding. If we have something like this, again, we just solve for the absolute value. So we add 30 to both sides. And we get 5 times 2x minus 8 is less than 50. We divide by 5. 2x minus 8 is less than 10. Now we can break this up. It's a less than case. So we have 2x minus 8 is less than 10, but also has to be greater than minus 10, because if it's more negative, we take the absolute value, becomes greater than 10. And add 8 to both sides, or all sides. We get 2x is less than 18, but also greater than a minus 2. Divide by 2 every side. And we get x is less than 9, but greater than minus 1. So that's minus 1 to 9. Okay. Now, lastly, we have situations where x's absolute value is greater than or equal to 6. So we have two situations. X could be less than or equal to minus 6, or x is greater than or equal to 6. Clearly, any number greater than or equal to 6 when taking the absolute value will be greater than 6. But it's more negative, like say x is equal to minus 10, then absolute value of minus 10 is 10, and that is greater than 6, so it works. So it's this one or this one, and that's our solution. So in interval notation, it's from minus infinity up to minus 6, and we include minus 6, so you use a bracket, union with, bracket, we include the 6 out to infinity, and we use a parenthesis here because we can never contain infinity. Okay, if we have something like this, we have to do it, whatever's in the absolute value, we have to do that. So we have 2x plus 4 is less than minus 16, or 2x plus 4 is greater than 16. All those points work. Solve for x, we have 2x subtracting 4 is less than minus 20, and x is less than minus 10. All those points work. And that's from minus infinity to minus 10, union with 2x and subtracting 4 is greater than 12, x is greater than 6. So that union with this, or from 6 to infinity. Okay, and graphically, 0, 6, minus 10 is not included, and then all these points, and all these points. So this is inequality, interval, and graphical. Okay, if we have something like this, we have to solve for the absolute value first. So 2 times x minus 8, adding 10 to both sides is greater than or equal to 28. Dividing by 2, we isolate the absolute value. All right, is greater than or equal to 14. So therefore, we use this as a greater than, so x minus 8 could be greater than or equal to 14. Adding 8, we get x is greater than or equal to 22. Union with, well, x minus 8 could also be less than or equal to 14. Less than or equal to a minus 14. Adding 8 to both sides, we get x is less than or equal to a minus 6. So we have both of those. That and that is our solution set. Okay, so in summary, understanding of absolute value, right? With equations, we can have absolute value of x is equal to 4, so x is equal to 4, or x is equal to minus 4. And if there's more stuff in here, you just have to solve for it. And then with inequalities, if we have a less than, then it's this case. If we have a greater than, then we have to do this or this. Well, I hope that was helpful to you to understand absolute value and equations and inequalities. And enjoy your learning. Cheers.